Okay, this lecture covers the convex mirror. At this point, before I immediately begin, however, go ahead and pause this video and take a look at my convex mirror demonstration video in today's folder. Okay, so notice that the convex mirror only gives you one type of image, so it's actually easier to describe, quite frankly, than the concave mirror. The first thing that we have to do, however, before proceeding through a basic example is we have to find the focus. Okay, so this is a convex mirror. This then means that the mirrored surface, by the way, is on the outside of the curvature. Once again, the first thing that we do is find the focus. Okay, so you always find the focus the exact same way. You find the image of a point object at infinity. Okay, so I draw the convex situation like so. The mirrored surface is on the outside of the curvature. Here's the optical axis. And then we just have our three light rays coming in from infinity parallel to the axis like so. We draw them nice and symmetrically. Okay, now take a look at the first light ray here along the axis. Okay, the axis itself is the normal line right here at this location. So then therefore the angle of incidence is 0 degrees. The angle of reflection is then therefore 0 degrees. And this just reflects upon itself. No difference here as what we saw with the concave mirror earlier. Okay, but now take a look at the top light ray. For the top light ray, this right here is the normal line. That's perpendicular to the mirrored surface at that location, and then therefore right here is the angle of incidence. And now what I have to do is reflect at the same angle on the other side of the normal line. That is like so. So right here is the angle of reflection. Okay, notice immediately what's happening with these two reflections that I've drawn so far, here and here. They're diverging from each other. So then therefore this means that they look like they're coming from behind the mirror. So the focus is going to form behind the mirror for that reason. Now before I draw it, let me also reflect this light ray as well. So right here at this location is my dotted line that's perpendicular to the mirrored surface at that location. Therefore right here is the angle of incidence. And now what I do is just reflect at the same angle on the other side of the dotted line. Like so. And then these three reflections, here, here, and here, well, they all appear to be diverging from behind the mirror. So now let me go ahead and use this color here in blue, like so, like so, and like so, and then right there is the location of the focus. So the focus is behind the mirror for a convex mirror. This distance right here is the focal length f, and in accordance with the sign convention, the focal length is now considered a negative number. And now let's just immediately jump to a problem here involving the mirror equation and the magnification expression. I could rederive if I wanted to, the mirror equation and the magnification expression by using a convex mirror, but frankly, we're not going to bother to do that. Instead, we'll just go ahead and use the expressions. And as we do, however, we do have to follow the sign convention. So now go ahead and copy down the second problem from today's lecture example into your notes. It's very similar to the concave situation from earlier. All right, so a convex mirror has a radius of curvature of 20 centimeters. For the following values of the object distance, calculate the image distance, magnification, and draw the ray diagram. Notice that I only have two distances here, 20 centimeters and 5 centimeters. As you'll see, the situation actually only just gives us one basic type of diagram. Nothing strange happens like it does in the earlier example of the concave mirror when you take an object and bring it closer and closer to the mirror. So the convex situation is actually quite easy. Okay, so first of all, once again, we're given that the radius of curvature here is 20 centimeters. Therefore, the focal length is 1/2 of that value. However, it is a negative number here, negative 10 centimeters when talking about the convex mirror. Okay, here's the mirror equation from earlier. Here's the magnification expression as well. And now let's just take a look at part A. All right, so part A, we're given that the object distance is positive 20 centimeters. So yes, the object is in front of the mirror, and now we just follow the math. So 1 over dO plus 1 over dI is equal to 1 over f. Okay, subtract the 1/20th to the other side. like so. And now notice that the number that I'm always going to get here on the right-hand side of the expression is negative, regardless of what the DO is. It doesn't matter if it's 20 centimeters or 5 centimeters like it is in this problem. The image distance is always going to be negative. So the image will always form behind the mirror for that reason. Okay, now mathematically, let's see, this is negative 2/20 minus 1/20. This is negative 3/20. Take the reciprocal to get the image distance. That's negative 20/3 centimeters. That's what, 6 2/3. So negative 6 2/3 centimeters. Okay, let's find the magnification, however, before I draw this out. This is a situation you haven't seen yet. So the magnification is negative DI over DO. Notice that the negative signs in the 20s cancel out, and you end up with positive 1/3. So you end up with an upright virtual image that is small. Okay, now this is a situation you haven't seen yet in terms of a basic drawing, so here is that basic drawing. Okay, the focus is back here, recall, behind the mirror. This is 10 centimeters. So this is 10 centimeters, this is 20 centimeters. So right here is our object like so. And now here's how you form the image. First light ray, once again, parallel to the axis. Okay, now be careful here. How does this reflect? Go back to my previous diagram and finding the focus. This parallel light ray, that is parallel to the axis, reflects off the mirror as if it came from the focus. So the easiest way to draw that very simply is to just do this, like so. And now what about a second light ray? Well, the second light ray that we always draw for the convex mirror is a light ray that goes from the tip of the arrow, once again down here to the center of the mirror. The reason why we always draw this light ray is because you can see right here the angle of incidence, and then therefore you just reflect at the same angle, like so. Notice that these two reflections here and here are diverging from each other, so therefore extend this back behind the mirror like so, and then right there is where the image of the arrow forms. So you end up with an upright virtual image that is small. So this distance right here was the 6 2/3 centimeters that we calculated for the image distance like so, and the size of the image here is 1/3 the size of the object. Okay, now in part B of this problem, the diagram is basically going to be exactly the same thing. The only thing that will change as I take the object and move it closer and closer to the mirror is the size of the image and where it's located in relation to the focus and the center of the mirror itself. But it's always basically the exact same ray diagram, so I'm not going to draw it again. Let me just calculate out what happens in part B of the problem, and then we'll just relate it to this diagram. Okay, now in part B, we're given that the object distance here is positive 5 centimeters. Once again, first of all, just follow the math. So 1 over DO plus 1 over DI equals 1 over F. Okay, subtract the 1/5 to the other side. Notice that the image distance is still going to be negative. So this right here is negative 1/10 minus 2/10. This is negative 3/10. Take the reciprocal here to get the image distance, negative 10/3 centimeters. So that's what, 3 1/3. Like so. So then therefore the image is a little closer to the mirror than it was earlier. However, watch what happens when I calculate the magnification. So the magnification is negative DI over DO. Negative signs cancel, do a little bit of math there, and it ends up being positive 2/3. So you end up with the image being a little bit larger than it was earlier, and it's a little closer to the mirror, but other than that, it's basically the exact same ray diagram. Take a look now at my demonstration video for convex mirrors. You'll be able to see all of this in that demonstration video.